Yeah, I think we can start the session. So this is an week 4 live interactive session. I will introduce again myself. There are some new joinees maybe. So I'm Swapnil Mane. Here I'm presenting or taking the session, interactive session on um, fourth week contents on social network course. So I'm a research scholar at IIT Jodhpur. I'm currently working in social network analysis and application group at CSC IIT Jodhpur. My primary area of research is in social network analysis and natural language processing. Okay. Yeah, let's start the session. So in this session, we are mostly taking the uh, some last year questions related to this week 4 content. So that will be helpful for solving the current year week 4 assignment questions. Okay, and also clear some doubts if you have any concepts you don't understand in the session that will be cleared in this session. Okay. Yeah. So let's move to the first question. So while taking the questions, we are also discussing some concepts. So might be you, if you are not understood, that here you can maybe you will get understand the concepts, or we can discuss here. Okay. Yeah. So the first question is that the people tend to have links to others who are similar to them. Identify this process that impacts the structure of social network. So what do you think that means? Which dynamics it's represented that sentence actually? People tend to have links to others who are similar to them, right? What do you think? Which option is correct for this question?
Option 3 selection.
Option one. So let's discuss. Any other response? Yes, any other answers? Yeah, if not, let's discuss each concept here. What is a social influence, triadic closure, selection between us, and what is the difference in between them? Okay, let's take an example and then we can have a discussion on that. So let's take a first a triadic closure that we have covered in last lecture also. So that is an triadic closure means one user is there and again, yeah. Suppose there is an user is there and there has an two common friends is there, right? And there is after some period of time there is a possibility to make a connection in between those common friends. So this the inserting or adding a age in between the common friends after the period of time, that is an triadic closure property. It shows an triadic closure property means, right, this user has an two common friends, and what is the probability or after some time they will make a friends actually. Okay, so in our real time friendship also that happens, right? You may understand that. So this scenario it represents an triadic closure. Okay. So then between a central, this is an one centrality measure actually. Between a centrality, say how we have where we have used last time. So between a centrality, we have used to make a or to create a communities, right? There is a network, right? And the whole network is there, right? Suppose this is an one network. I'm bad at drawing the network actually, but it's fine. Maybe you can understand. These are the edges and these are the nodes here, right? So between a centrality, what we are calculating uh, in the between a centrality is calculated for the each edge, right? Instead of the node. So for each edge, how many shortest paths from passing from those edges actually that we have to calculate it. So you can see here the shortest path for this edge. Suppose this is E1 edge, this is E2 edge, and this is an E3 edge. So the shortest path passing from this E1 edge comparative to this E3 edge, right, it's very less, right? Because you can see the one node is passing from this node and another node can pass here, So suppose the only one shortest path is made for this, maybe, right? And you can see for this age, for three nodes visited, for visiting the another side three nodes, it should be passed from uh, this middle age, that is E3 age, right? So the betweenness score for this age is very high. So in community detection, what we are community building or community creating, what we are doing there, we are removing highest between centrality ages, right? So which age has an highest between centrality? We are removing those ages, and then we are checking that it is unconnected or not connected. Right? If it is connected, then we have to again calculated the between centrality for each ages, right? And then the the iterative process needs to continue still when the uh, network is connected or not. If it is not connected, disconnected, then that at that time we can stop there. Okay, if you want three communities separately, at that time we have to also check how many components has been generated, right, after removing the betweenness, after removing the ages, right? So I hope the two concepts maybe you have cleared or recalled those concepts that we have covered, or that we have that you have listened in last uh, week. Okay. So let's see this what is an social influence here. The social influence is already Dr. Iyengar has already given intuition about this social influence. That is, an suppose there is an user U1 is there and user U2. They are already friend. Okay, they are already friend means they have already one connection in between them. In this U1 and U2, so U2 user is eating. That is the same example, or we will take, or let's take a same example. That is an it is an eating mistaken. It is eating a burger. Suppose it is U2 is users has an habit to eat regularly burger in every day. It is a he should eat a burger at 4 p.m. Right. So he is a close friend to U2, or that is a maybe friend to U2. After some period of time, he is also influenced to eat this burger, right? This is a social influence. Because of my friend's influence, I'm going to visit that place, or I'm going to eat that food, right? So that is a social influence concept. Actually, that is an intuition of the social influence, right? So because of my friends, I'm influenced to take some actions, to do uh, some to take some actions, or to behave something, right? Behave something like my neighborhood friends, right? So these are the neighborhood friends, right? So currently I'm also so that is a different point. I'm also working on the same problem, that is in my how my peers is behaving. Based on that, what is my behavior after some period of time, right? If they those peers, my neighboring nodes, my friends are aggressive at a particular moment of time, at that time I'm also aggressive or not. I'm also speaking hate speech, or I'm also behaving any weird things or not. That I'm doing study currently. Okay, that let it be. That then another part. Yeah, someone is asking, sir, recorded video of the lecture. Yes, the recording of this video lecture will be available on the YouTube. Okay. So okay, yeah, let's discuss after the session actually. So maybe you have cleared the what is in social influence. Because of my friends, I have influenced to do some actions, or to behave something like friends, right? Right. That is word itself represent means itself explains those intuition actually. Okay. Another thing is in selection. So selection, it is an because of something, because of means because of something, or because of some reason, I have make a friend with particular user. Right? Suppose uh, suppose the Neeraj is there, right? So one person is, I'm taking randomly number here, but still. So Neeraj wanted to work in social network analysis in this domain, right? So what Neeraj it's from the some reputed institute, or it's as an reputed researcher. He's connected from any social media platform, right? So he's connected because of he wanted to work on that social network uh, field, right? So because of something related concept, he has connected to that particular friend, right? So this is a selection process happen. It's not the uh, based on, suppose let's take another example, that is an same example we have considered, that isn't focal maybe, but so yeah, the selection, maybe another example, what we can do, Wikipedia example already has taken, that is, and suppose someone user one is talking on other users has found interesting comment of this user one, then he's also try to communicate with him, right? And after some time they are make a close friends, right? And their discussion in between them after over the period of time is similar, right? Contextual similar means their thoughts matching in between them, right? So here you can see the people tend to have links to other who are similar to them. Similar to them, likewise, it is in social. Trying to working on social network, and another person is also working on the social network. He wants to make a friend in between them, right? Likewise, so that another example has already taken in the lecture, that is, in suppose user one is in class A, and there is an also one person, he or she is also from the topper in another class. They make a friend, right? So because of similar properties of users, right? Yeah, so the correct answer for this question, it is an selection actually. Right. Yes, have you understood, or is there any doubt still? If you have, we can have a discussion again, okay?
Understood, sir.
Yeah. So the question two, given two authors are editing, that is same example we have discussed. Yes, the question is right. Two authors are editing articles. Number of articles edited by both author A and B is 10. Okay, the total number of uh, articles than 10, irrespective of topic. Okay, the total of articles edited by them is 18. The similarity means these are the common topics which has means common topics means they have edited on common article, means A and B is, suppose the article A is there, so sorry, XYZ is there. This is one article XYZ name, and they have edited this one XYZ, two XYZ, up to 10, right? So these are the A and common edited topics, right? Right, up to 10. There is also other articles are there, but it's an individual edited articles. It's not with respect to the in means common articles have there. So these are the total number of articles are 18. Okay, and these common articles are the 10. Right. So these two information we have they have given. So based on that, we need to calculate it. What is the similarity in between those two users? Right. So can anyone give the answer for this question? Is anyone?
Option 2, 10 by 18, sir.
And why is that?
The formula for similarity measure is both common neighbors of A and B divided by Total neighbors. The common neighbors of A and B is 10 and the total neighbors is 18. 10 divided by 18.
Right, right. So the similarity measure is calculated, which is an common article. Here is a relation, which is a common article between the A and B divided by total number of uh, articles edited by either A or B. Okay. To- Total number of article which is edited by either A or B. Okay, so based on this, we have a common article which is 10 and total article which is an 18. So there is a direct option has given and two option. Right? So I hope this question is clear to everyone. Right? Yeah, let's move to the another question. Dynamics of friendship formation and behavior of people in a network is affected by selection or social influence. So what do you think? What is the correct option? So the yeah.
Option 3, both selection and social influence.
So here the what is your intuition to why do you think this option is correct? Selection and social influence. How it back to the friendship? Yes. Yeah, going to me.
So repeat again. I can't hear you.
No. Hello. I'm audible. Hello.
Sure.
Yeah, I'm asking that how this both of these concepts is related to means how it is affected to the friendship network or dynamics of the friendship formation. How it is related.
So a network is mixed of any kind of friendships. So, dynamic friendship. Sometimes a friendship may be network may be changing. Sometimes I have a friend with a non-technical person. I want to friend with a technical person. That time I change my network, and sometimes I visited some bad habit persons. I also change my mindset. So sometimes the network may contain both selection and social influence.
Yeah. So that is the so this is an two as already told by Gautami, it is an correct intuition. So the selection and social influence, how the friendship is made, the means based this selection, the friendship is made by the similar properties. By seeing the similar properties, the friends are making becoming a friends, right? And social influence is it is an also making a means suppose let's take a one example that is in two users. I already said that user u1 and user u2, there suppose u2 is going to the canteen to eat an burger, right? u2 is also influenced to go to the canteen, right? So they both together goes to the canteen. So they found or they found some other students there or other users are there in the canteen, so they will make a friend in between them if they found similar what we can say similar dominance or similar profile user in between them, then they will become also a friend, right? So that is one a dynamic nature of the friendship network that is happen by using this selection and social influence friends formulation. Okay, the option is 3 is correct here. Okay. Yeah, this question it's related to the maybe the triad closure needed, right? So let's have a look into this question. Please take a time and look into this question, and what do you think, which option should be correct and why is that, right? Okay, I will read the question. Suppose Hari and Joy have a k number of friends. Okay, so let's draw here k number of common friends, right? Suppose let's take these are the k number of common friends, A and B. Right. Given that each common friend gives Hari and Joy as an independent probability of P of forming a link in between them, a link in forming the link of A, right? A or respectively. What is the probability that there will exist a link between Hari and Joy, right? So we need to find that what is the probability while considering k number of common friends. What is the probability they will make a friends, right? So already has this formulation has been taken. I already I will also take some intuition of that. So is there any answer for this question? Yes, anyone? It has already taken in the lectures actually. The same concept, same intuition has already described in the lectures. Right. Okay, it's fine. I will also take here. Yeah, Kumar, go ahead. What is your guess? Yes, Kumar Neeraj. Option C. Yeah, it looks familiar. Somewhere you saw this equation, maybe. Yeah. Is there any other options? Any other answers are there? Anyone? So see here. So we know that there is an suppose probable. Let's take a P as an probability to have a friendship in between the A and B, right? With along with a one common friend, right? One common friend. Written is very bad still. Hmm. So let's take a P probability. It's already given that. So it is a probability of age in between the A and B while they have a one common friend. Common friend. Okay. So what is the probability for the if they have a not friendship in between them, means there is a no age for the age between A and B? What is the probability for that? That is we have already studied in the probability, like, right? So it is and 1 minus P. So this is the probability for age between the two users, and this is the probability for there is a no not an age between the two users, right? That we have seen here, A minus B, right? For the same one common friend. So same has been, so this is already proved in the research paper that has an already explained in the lecture. That same intuition I have taken here. Okay, that will be maybe helpful for to recall the concepts here. Okay. Yeah. So this is this probability we have found, that is and for the single common user, right? That is one common user in between the A and B, for the A and B user. Suppose there is an k number of common friends are there. So at that time, what is the probability of A and B? For the there is a no friendship, right? There is a no age between, means probability for uh, they have an they have not in friendship. There is no age between in between them. So what is the probability for that? That is a 1 minus p. It is for there is no age in between them for the while they have a k number of friendship, right? So this is the formulation for the probability which has A and B that does not have an friendship relationship, right? While they have a k number of common friends. So if this is an not negation probability, that is an uh, they have not in friendship. If, let's take, and what is the probability for the so let's take this term is and what we can take, it is an x, right? So this is an x probability, it is an x terminology we have to. X probability is for the not an age between the A and B having an k number of common friends. So for probability of, if there is an age between the user A and B while having the k number of common friends, what is the probability for that? That is an 1 minus x, right? Are you agree with this? Means this is for the not having age between them, and this is an having age between them along with the k number of uh, k number of common friends. So the final equation may be look like 1 minus p divided raised to k, right? So this is a final probability of an age between A and B having an k number of common friends, right? So option C is correct, right? Here. I hope you have understood. If you not, please let me know in that case. Yes, anyone has any doubt?
So repeat the concept of the probability only, sir. P, what P denotes, what 1 minus P denotes, and what 1 minus P whole power K denotes. The concept only repeats, sir, please.
Right. So the probability P here represents what is the probability, means how means what is the probability having an age in between and B, A and B. So that is probability. Suppose I have a k number of, suppose let's forget the k actually. So there is an one confidence score. Suppose there is an user A and B here, the same example we can take. There is an score. Suppose an confidence score is an, there is let's, in the example I has already taken as an random probability value, right? That is and zero point 0.3, that 0.3 percentage or 0.3 confidence, means suppose there is a 0 to 1, the range is there. 1 means there is an age between them. The less than 1, that is a possibility to have an age between the A and B, right? So here we are finding that what is the probability of, or what is the confidence of of an having age between the A and B, right? Here we are trying to quantify that how the age and means what is the probability of that particular age, right? So so for finding here, so here the p is representing the probability having the age in between the A and B. And suppose let's take another intuition, that is, and there is also we have taken the another term which is an 1 minus p, which represents there is an what is the probability which has there is a no age possible in between this A and B user. So this is an 1 minus p probability, right? So considering this, so at this time we have considered there is an only one neighborhood and one common user is there. So at that time we have we have considered the p probability and 1 minus p probability for for having, for does not having an age in between A and B, right? So So this term, two terminology might be you cleared, right? So this example we have extended for the k number of common friends, right? Suppose, right, I will consider here. Suppose this example we have taken it here as well, right? So we have a probability which is and does not have an age in between the a and b, that is in 1 minus p. Let's take an k number of common numbers is there. Well, this probability is for the one, only one common number is there, right? Let's take an k number of users are there, and those are the what we can say, those are the common numbers of this, or we right, those numbers also. So in this case, the previous one, it is an for this it is an one, right? The common neighbor is an one, only one, and that at that time this condition is, this equation is satisfied, 1 minus p raised to 1, that is an 1 minus p, right? So the similar intuition we have taken here for the k values, which is an 1 minus p for the k number of common numbers, right? This we have got the probability for does not have an age between the a and b. So same intuition, this probability is taken as in one term here, right? That is x, which is represented as in probability has having does not age in between the a and b. Let's take a probability having an age between the a and b, considering k number of neighbors. So the same, the probability we have for the one side, one case, that is another case for the probability is an 1 minus x, right? And the x represented here is an at 1 minus p raised to k. Here you can calculate the probability, which is an number of common users, right? Number of common neighborhood, right? Number of common neighborhood, and divided by total number of what we can say, total number of having friends of a and b, right? That might be take a probability, right? If they have a, suppose and um, they have a common friends is an suppose 5, and how many has total friends of either a and or b, so 20. So this might be a one represent a score or confidence score in between the user a and b. I hope this might be helpful or to understand or recall the concepts. Yes, is it understood or still have any doubts? Yes, I'm audible. Hello, hello. Yeah, yeah. I think you might be understood. If not, please let me know after the lecture, and we'll discuss in detail as well. Okay.
Repeat the fifth question, sir. I can't understand.
Sorry, your voice is breaking, Gautami.
Repeat the fifth question, sir.
Fifth question we have not discussed yet. We have
Okay,
discussed
sir. I
three
have.
questions.
Sir. Okay, sir. I understand fourth question, sir. I understood.
Yeah. Okay. Yeah. So let's discuss the fifth question. So this is the part for the this fifth question, right? So the question 5 is an Ram and Raghu met, uh, joined a yoga class. Their similarity measure was 0.005 at the time of joining. They become a good friends on day 3. What is the similarity measure right before they become friends? So please recall the concept. Right, is in similarity of the friendship. Right. Please think on this question and try to uh, try to solve this question. Means what could be the answer for this question? Take a time. Point not four. Why point not four? Is there any reason or this is an guess actually? I'm not understood because someone has given already that is one guess for C option. Might be they have. Yes. Why point not four? Yes. Anyone? Have you solved it or still you have not understood the question? Okay, I think I will discuss. We will discuss it. If you have any doubts or if you want to discuss anything, this is an two-way interaction session. Okay, it's not an one-way. I am discussing continuously, means talking only single. I'm also bored actually. Okay, so if you have any doubts or if you want to point out or add something in the discussion, uh, ping me in that time. Okay, yeah. So the question says that there is a two person, Ram and Raghu. They met at a yoga class, right? And their similarity means what their uh, discussion or what their thinking after some period of time, right? Suppose you made a friend, and after some 10 days or something, some period of time, your talking or your perspective and his perspective is something similar, right? That's called here as an similarity, how much their thoughts are similar to each other, right? So the similarity measure, which is an how much they are similar, which is an point not 5 at the time of joining. At the time of joining, okay, uh, they become good friend on day 3. Okay, what is the probability measure? So I will draw a graph. By watching this graph, you might recall the some intuition or some concept that has been discussed in the lecture. Okay, so there is this type of graph, right? Hmm. This is an time period, and this one is and similarity in between them, right? And so their similarity measure was at joining. So they have suppose t is equal to 0. T is equal to 0 means while means the time they met together, right? That we have taken t is equal to 0. T is equal to 1 means after they after one day, after they met, from that means after joining the session, joining the yoga class, from that one day, that is in t is equal to 1, t is equal to, right? Likewise, so there isn't too much so so here t is equal to 0, t is equal to 1, t is equal to 2, t is equal to 3, design time period, right? 3 means third day, right? And similarity means, suppose they are close friends, suppose they are close friends, their similarity is very high, that we have seen, right? If they are not that much close friend, their similarity is not, their contextual or thinking similarity is not that much matching to them, right, in between them. So that we know, that intuition we know, that so let's take an at t is equal to 0, their what do you can say, their similarity is in point not 5 here, and here the value is point not 5, right? And we found that, means they have claimed that, that is an at t is equal to 3, the similarity means friendship is, they have become good friends. Right? Good friends means, let's take an, it is in greater than this similarity, right? Might be, I don't know how much that similarity is it, but it should be greater than, greater than point not 5, because they are good friend after meeting this. That means it takes the graph like this way, maybe. But before meeting, what is the similarity score, that the question is asking? Before this t minus 1, before they are meeting you, t minus 1, what is their similarity? What is you can give a some condition or perspective, what could be the possible similarities there?
Option 2, 0.004.
Yeah. So why is that?
Because the T0 is 0.05. So before we become friends, the possible values are 0.04, less than 0.05.
Right, right. So we are not quantifying. Suppose let's take a, we don't have these values. Okay, we don't have the options are there. But we know that before they are meeting at the yoga class, that is at t is equal to 0, means t is equal to t minus 1, or t is equal to minus 2, their similarity is, should be, it should be less than point not 0.05, not 5, right? So that intuition we know, that confidence or that perspective we know, that based on this perspective which option is correct, that we need to find out. So this option is not correct, it is greater than point not 0.05, which is falls into this section. This also falls into this section. This is on to t is equal to 0, right? But before they meet, how they know that uh, their similarity has an point not 5, right? So there is an point not 4. It is incorrect option for this. Yeah, let's see this question. Question 6. Given the friendship network in a dance crew, 5 girls represented by red notes, right? Um, these are the girl girls note, right, represented as girls note, and this represented as an boys notes. Find the homophily of the network. Yeah, take a time and please try to solve this question. Okay, try to solve the question and please let me know what could be the answer for this question. First, recall how homophily we are calculating, how we are quantifying the homophilia. I don't know exactly there is a negative marking in the final exam. Please go through the guidelines, or there is might be given a documentation. Might be there is a negative marking. I don't know exactly, but you can find on the NPTEL documentation, or the social network homepage. Yeah. So is anyone has solved this question? How we are quantifying the homophilia of the network? So homophilia means what? We are taking a age. So what could be the probability, and what could be the probability of an age which has a node from a one girl, and from one node is and from boy. So how we are calculating in probability here of, right? If that probability or that score is high, then there is an no means there is no possibility of homophily. Yes. Anyone? Yeah. Hmm. Yeah, let's discuss it. Hmm. So the homophily we have quantified. We need to what homophily represents. That is, and there is an two networks is there, that is and densely connected in between themselves, right? So let's take an one network which is, and they have densely connected in between themselves, right? And there is another network. Then another network is a part of the network. Actually, I'm not. It's saying it is an this one, right? So they are densely connected in between themselves. Okay, right? And there is few edges which are connected across the across domain, right? Right. So this represent one homophily, right? That is we can say as in similar minded users are there. These are another group is in similar. Their similar minded groups are there. Has taken an example, similar example has taken in the lecture, which is an this is an teenager users. This is an teenage user, and this is an middle age users, right? So these are most not talking to each other most of the time, but the teenager students or users, they are talking in between, or they are sharing the things in between themselves more comparatively to the middle age users, right? The middle users, they are talking in between themselves, right? So these are the similar thoughts peoples are there in between users. So here you observe that the when suppose let's take another example, like there is an these nodes are there, right? And the ages are there across the ages are there across the two domains users, right? Now there is few edges in between themselves, only few edges are there. So do you think that is there is an similar minded users are there here, right? As look into this example, we are getting as in similar means clearly similar minded groups from this network, right? Which represents as an homophily. Here the homophily is very low. That means here the heterogeneity of the network. Heterogeneity means what? There is an different minded users, right? Different domain users. So let's take, and this is an computer science domain users are there. This is an let's take as an basic science users are there, right? These are the similar topical users are there. It represents an two separate uh, community, or we can say a group of people which has a similar thoughts. Here the heterogeneity is very high. Heterogeneity, when the heterogeneity is very high, when the homophily is very low, right? Homophily is very low. At that time, heterogeneity is very high, right? Here the heterogeneity is very high. So the similar concept we have applied here, that so we need to quantify the homophily here. How much, what we can say, how much ages uh, across the domains, across the group of peoples. Those are the three, right? There is a formula. Actually, I will discuss first the formula, and then let's put in values in between in that formula. Okay, let's take and look into the formula first. So let's, so the formula is that actual ages across the group, across the two groups. Here the two groups are there, the boys groups are there and girls groups are there, and we need to find how many actual ages across these groups, boys and girl group, right? Divided by what is the possibility or ages expected ages across B and G. So the one concept that I think you got the formula, maybe, right? The formula is clear. The actual ages across the A and boys and girls group, and divided by expected number of ages. So you might know that as what is an actual number of ages that you will get, that is, an four ages are there, and divided by expected, what is an expected number of ages are be there here, right? So that we have discussed in the you might be has learned in the lecture actually, that is, and suppose we are randomly picking the age, right? So randomly picking this, what is the possibility, what is the probability that age has endpoints which has an which is an either boys and girl, right? So age we are picking, that is in boys, and what is the probability for this, that we have seen, that is a 1 by 2 probability. So how the 1 by 2 it's getting, that is an, as we have taken a same example, that is an suppose we have a two coins are there, that you might be seen or learnt in the basic probability, right? Two coins are there, right? So we need to find the probability for the head tail head, and tail. So let's take the similar example. So the coin 1, coin 2, head, head, tail, head, and tail. So what is the probability for each case? That is a 1 by 4, and 1 by 4, 1 by 4, 1 by 4, and 1 by 4. Right. So here the boys and girls. So we are taking considering the two scenario at a time. That is, and head, either head or tail or head. Right. So what is the combined the probability for these two scenarios? That is an 1 divided by 1 by 2. Similar way, we have to check why we are taking these only two cases, because we have to check uh, the less number of ages. Here you can see the less number of ages, which shows that uh, the homophily is very good, high, right? So we are quantifying these ages. How we are quantifying the ages? we are finding the probability or expected number of ages which has an different endpoints. Here is in boys and girls and boys, like, so we have an 1 divided by 2 probability which will be possible, or which will getting uh, after picking the age from a network which has an either boys or girl or boys, right? So here let's count the number of ages. I think you understood that how the 1 by 2 it comes, right? For picking a age which has an different endpoints. Right? Here, let's first count the. In this case, how we are calculating the expected ages. Let's see that. Okay. So let's count the one, two total ages we need to count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. This one is right. So there are total 16 ages are there. So from the total samples, as we have seen already that there is an there is an probability on age which has an either different endpoints, which is an 1 divided by 2. So from the 16 samples, what is the probability of picking the age which has an different endpoints, which is an 16 divided by 2, which is an expected number of ages, right? So so we got as in two values. Firstly, the first is in 16 divided by 2, 8, right? And that is an actual values, we know that is in four values are there. So let's put into the formula 4 divided by 8, so 1 by 2, right? So the answer is 1 by 2. Yes, have you understood? Is there any doubt? If you have any confusion or any, if you have not understood, please let me know. I will repeat that portion or repeat the concept. Hello. No doubt. Okay, let's move to the another question. Which of the following condition is ideal for good community? Yes, this answer you should have answer actually. This is very simple question. Yes, which option could be?
Option one, sir.
Yeah. Is there any other answers are there for this question? Anyone? Yeah. So let's understand what is an intra and inter community. Right. What is an intra community ages? Anyone? Intra. What is an intra and inter community ages are there?
Sir, inter means within the community, intra means another community.
Right. Intra means inter means that is an across the community, right? So yeah, let's, you can visualize like that. It is, and suppose this is number of nodes are there in this site, and there is an intra community ages. Suppose let's take any one community. This is another. This is another community, right? There is an dense connection between them, and here is also dense connection, right? And some few connections are there across the community. So here you can see this represents one community, this represents one community, and it has these are the inter inter community. These are the inter community ages, right? And these are the intra community ages, right? So you can see here the intra community ages, which is in higher than the inter community now. So the option one is correct here. I hope you understood. Okay. Identify, let's take next question. Identify the network mechanism in a play for following transformation. So yeah, the option is that triadic closure is it. This transformation has been happen for as because of the triadic closure, structural hole, focal closure, or membership closure. So what is the answer for this question? It's very simple. Maybe this has been yeah, Gautam. Yeah.
Option 3, focal closure.
Is there any other answers from other students? Option B, Neeraj, why is that B? If it is wrong, please also don't hesitate to answer the questions. Okay, wrong answer. It fine? Okay, at the end we are also discussing the questions in detail as well. Okay, Wha- so Neeraj, why is the option B is correct? Why do you think that structure is whole is correct? What do you mean by structural whole? Yes. Let's see. So we have previously discussed uh, the structure, triadic closure, right? Maybe these three things we have not discussed. Let's discuss it. So the what is the structural whole? We have discussed in the previous last week interactive session. That is, and we have a community. Right, different two communities are there. Right, and from this community, there is only one age is there. So here it represents a structural whole, right? If you can remove this, there is a loss of information, or you can't communicate with the other community. This is a structural community happens in this scenario. Okay. So the structural whole concept is different than this. The focal closure and membership closure is there. It represents in between the two users, how two users or in between the two entities, right? On the relationship between the two entities, how it is becoming friend, and on which basis they are becoming a friend, right? Based on these concepts has been designed. That is an focal closure and membership closure, right? Let's discuss the first membership closure, right? Membership closure, that I think we have discussed earlier. It is an so empty space between contacts in a person's network, right? User 1 and user 2 has connected, then user 1 is going to gym, right? So based on this user 2, u1 is also joined the gym. That is a membership closure, right? Is it correct what I'm saying? Right, this is a membership closure, that if they are friend together, and one of them is going to the gym or any other part. He's also go to the gym, or he's influenced to the to participate in that particular gym. So the let's take an focal closure. Focal closure, there is an gym, right? And in that gym, two persons individually coming to this gym. Before coming to gym, they are not friend. After coming to this gym, they make a they having a friendship in between them. Okay, so that is an focal closure. Because of some entity, they made a friends, right? So you can see here that in a sports club, that Anu and Raj, they had joined the sports club. After joining that, after some period of time, they had become a friendship. They had a friendship relationship between them, right? They had friend after some period of time. So that is a membership closure. So this, sorry, focal closure, right? So option 3 is correct here. Let's move to the next question, which is, and when calculating the homophily value, what range of values is expected when the network exhibits heterogeneity? So, what is the correct answer here?
Less than one.
Yeah, other than Gautam, is there anyone to answer these questions? Is anyone? Yeah, we have this range is already discussed in the lecture as well. And what, suppose the homophily value is 0? In that case, what could be what do you mean by uh, what the network exhibits in that case?
There is no homophily.
No homophily, that is correct. But how the network exhibits in that? How the network means it is a randomly generated the ages actually. And greater than 1 means greater than 0, sorry, greater than 0 to 1.
It is a homophily network.
Right. So it is a network. So here the option is 3 is correct, less than 1, which is an, it shows an heterogeneity. There is a no more an homophily in between them, that we have saw as an in lecture as well. That example has been discussed, the celebrity network, right? Celebrity network, as in our class network, let's take a class network. And as we know that in class networks, there is an a group of, there is an girls are there, but in the girls, in between them, there is an connections are there, they are discussing in between them more as compared to the boys, right? Means, right, in boys there is an dense connection in between them, because they are discussing, or they have means they are close to boys rather than the girls. There are some exceptionals also there. That is an some, means there is a generic network perspective I have drawn here. There might not be cases there, but I have taken a general perspective. Okay, so this one is some ages are there. So you can see here the across the ages are very less. So here are clearly shows an homophily. There are similar minded or similar gendered um, gendered users or people are connected densely together, right? And in celebrity network, suppose let's take, and this is in girls and this is in boys, right? So there is an, suppose female male are there, it's female, and another is group of users which are the male. In that in this network, observe that the across the ages is very high compared to the as compared to the in between the users, in between the community, right? So you can see here the across the edges are there. So this represents the network as an heterogeneity network. Individual has a different minded or different intuition or perspective they have. So this represent and less homophily, which shows as a heterogeneity, right? As we already discussed, then homophily is very less means near to zero, right? And after that, heterogeneity it can be shown. It has been shown. Yeah, this is a last question. Which phenomena is represented in region B of the given graph? Firstly, what this graph represents? Can anyone explain? I think this graph we have already discussed in some before question, maybe.
Wikipedia network.
Yeah, Wikipedia network. So in this Wikipedia, what do you mean this graph represents? What exactly it suggests?
Social influence.
No, I'm asking what this region A and region B represents specifically. Yes. So the region A that has been observed in the research is that the region A, which is and means before they are meeting, before this is time period actually, right? Over the period at time t is equal to 2, how much similarity in between those users. This is an average similarity has been taken between the users. Okay. So for sake of simplicity, let's take on two users. Okay. So as we have seen this example, this explanation before, some questions I'm not remembered which questions we have uh, explained this graph as well. So let's take on two users for the sake of simplicity. So over the period of time, let's take their similarities here is very less, near to zero. Right? After some period of time, their similarity goes higher. Right? And they have met at some period of time. This is their meeting time. Means they met on some conference or some meeting, right? After meeting, you can see their similarities goes very higher, right? Here we have to see this is an means this is an steadily increasing, and this is an something a steep. It is here it is not shown, it is very steep, but it has been shown in the research that is an the before they are meeting, the similarity in between the users, it is an steeper means that they are which is their they are become a friend because of their selection means they are seeing the properties. If their properties of other users has similar to them, then they have made a friend, right? But after making a friend, their similar or their contextual similar or thinking is more goes similar, means similarities goes higher, right? There means suppose user A is there and user B is there, right? Suppose user is talking on some topic one, right? And user B is also trying to influence, or after some period of time he's also influenced by the user A, he's also talking on topic one, right? That is an the similarity of contextual means similarity between the users on talking on similar post or similar topic is going higher over the period of time. That shows they are influencing each other, right? Here this part shows an influencing to each other, that is an because their similarity is going higher, right? So take one example that we have already discussed. User 1 user 2 is there. He's suppose he was already they are already friend, right? They're already friend and he's eating burger. So after some period of time, he's also goes to the eat and burger. That is an influence, right? So they he's influenced by his mind, right? That is an their similarity has been increased at this time, right? It is not has been means he's not going eating it at day is equal to one. Just they have met and directly they are going to the burger because he is saying, but he's not like to eat the burger. It's not going to the burger eating burger right at that same day on day one. But after some period of time, if their friendship is very close, he's also influenced by his friends. Right. Okay, I will also go with you to take a burger, or he's forcing him or influencing him, yeah, taking this burger and likewise. Okay. So this is a social influence, represents a social influence because they are influencing each other. Because of influencing each other, their similarity of thoughts or thinking it's going increasingly. Right. Similarity of in between the users going increasingly. Right. Yeah, the option two is correct here. Yeah, overall, is there any doubts or any you want to add something, or is there any suggestions or anything? If you want to take some other points or any concepts, please let me know. So in that case, I will prepare those also and we'll discuss on that. Right. Our ultimate aim is that we have to clear the your basic doubts or you are confusing any some period of time of, while solving the assignment questions. We'll discuss in that question. Okay. We are not discussing directly the assignment questions in the current years, but we'll discuss the concepts, what the concepts mean by, right? No doubts. Okay, yeah, that's fine.